Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Bouncing X Sums by Lizzie1. And here are the rules, and they're not in the actual rule set here. I will provide a summary of the rules actually in the description so that you can actually just use that as a reference. But here are the rules. There's not very many, actually, so don't worry about it being too much. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Also, clues outside the grid are the sum of the first x digits in the corresponding direction. These sums may bounce off the edges of the grid and continue at a 90-degree angle if x is larger than the number of cells in the diagonal. So this is essentially, and that's why this is called bouncing x sums, because it's kind of a combination little killer slash x sum clue. Little killer just because it's diagonal, but it's also x sum because the x is obviously the first digit, and it's a sum of those first digits, right? But it can be obviously up to 9. And for example, if this were, say, well, it can't be 9 here. Well, actually, this does tell us some information here. Huh. Okay. Actually, it doesn't tell us that much information. But let's just say this was actually 8, right? Then to add this bouncing x sum, you would have to add these 5 cells plus these 3, right? Because these add up to, so since this is saying let's add the first 8 digits, it's count the first 8 digits here, then bounce off the wall and go in a 90-degree direction, which is here. And then count the next 3 cells here, right? So it counts the first 5, hits the wall, then counts the next 3. And so you can think of it as an x sum along a diagonal, but it can also, the diagonal could also bounce off the wall. So it's pretty cool, actually. I've actually never done essentially an x sum along a diagonal route either. So this is actually new in multiple ways for me. But it also bounces off the wall in a 90-degree angle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, and also, you can have repeats, obviously, along the diagonals, right? Because they're not disallowed, and we also have x sums which are greater than 45, which if you did not have repeats would not be allowed. But since they are allowed, therefore they have to have repeats here. Anyways, that's how bouncing x sums works, and that's the only other rule besides normal Sudoku rules. So if you'd like to play along, there's going to be a link in the description, and we're going to have an actual description of the rule set in the description. So you should be able to refer to that to be able to actually remind yourself of what the rules are. Which is, again, it's just normal Sudoku and this new bouncing x sum rule set. Anyways, that's going to be in the description, and now I'm going to play. Let's go. Okay. So what do these all mean is the like this is 55. This is 56, but it's along the same diagonal. That's interesting. What does that mean then? This can never be the full 9, right? If this is the full 9, this is saying that the full 9 adds up to 56, but then you have one other digit there, which adds up to 55. This would have to be 1 then, at least, because, or sorry, This is, okay, so what, this diagonal is actually very important. If we try to have this add up to not with 9 digits, the problem is, say this was 8. If this was 8, that means like, okay, let's just go this way. Say this was 9. That means the full amount of these by themselves would have to add up to 56 without this. The problem there, then, is this is saying the rest of these are 55. But to add up to 55, first of all, you would exclude that, which would be 9. And therefore, it would have to be less than 50. This would be 56 minus 9, which is 47. But that's not allowed. So that's why this can never be 9. So it could be 8. That's quite possible. And if it is 8, that's actually very interesting. Well, okay, so if this is 8 and this is 8, that doesn't work. This can never be 9, right? Obviously. And this can never be 9 because this would then say all 9 of these cells add up to 56, which is obviously 55, which would break then the bouncing exsum the other way, right? Because then 56, you can never get 56 with 9 or more. So this can never be 9 either. But this can't be 8 either, because if this is 8 and this is 8, because this can never be 9, the problem is they would both have to add up to the same values. So this has to be at most 7 here. And this is at most 8. Can this ever be 6 is kind of the question, right? If you have 6, that would force this to be 6, 8, and 9 at most, with 7, 8, 9 at most. And that would add up to 24 plus 23, which is 47. So no, it cannot be 6. This has to be a 7. Sorry, this has to be a 7. If this could be 7, actually. This could be 7 or 8. We're not sure which. This is 7, so this is at most 7, 8, 9 plus 7, 8, 9, which is 24 times 2. Therefore, this is 7, 8, or 9. So we have 3 degrees of freedom, or 2 degrees of freedom, along these 7 cells. Right, 7, 8, 9 plus 7, 8, 9. Can this ever be 6? No, because it's similarly bounded. 8, 9, 8, 9, right? So this has to be at least 7. So it's 7, 8, 9, 7, 8, 9. This is, therefore, that's 24, 48 plus 9 gives us a maximum of 57, which gives us 2 degrees of freedom here. So the 8 could drop to a 6. So we know there's always a 9 here. There's always a 9 here. The 8 could drop to a 6. The 7 could drop to a 5. But this can't be dropped because this is specifically 7. So this has to be 6, 8, 9, 6, 8, and 9 here. This could be 5 through 9. And obviously, this could be 7, 8, or 9, with the 9 being able to drop 2 down to the 7. And I say degrees of freedom because it allows... I'm not sure if there's an actual term for it, but basically it's the degrees of freedom this diagonal has for the lowest digit, the lowest non-set digit to basically drop, right? So here it would be 7 dropping to a 5, but the 8 could also drop to a 6. This is the 8 dropping to the 6, and this has to be a 9 dropping to a 7. We know a 9 has to be here, though, because a 9 cannot drop to less than a 7 with only 2 degrees of freedom. Okay, what happens if this is 8? If this is 8, we know it's these 6 digits minus 7. So therefore, it would be, this would be 55 minus 7, which is 48. So this would have to be 48. The 8 would add up to 48 with 56, and this would be 1. So this can never be 8. Therefore, this is also a 7. Right? Because if we made this 8, it adds up all of these cells, and we know all of these cells, specifically these 6, must add up to 55 minus 7, which is 48. This is an 8, so that's an 8 plus 48, which is 56 already. This can never be a 0. So that doesn't work. So this has to be a 7. So this counts these 7 digits. Well, what's the max here? The max here would be 7 plus 8, 9, plus 7, 8, 9. So this is 24 here, 24 here. That's 48. And 9 is 57. So it's the same max, but then there's 1 degree of freedom. So this cannot be 6 here, first of all, because the 9 could drop to an 8 here. That's a 1 degree of freedom. This is the 7 dropping to 6 at most. So this is 1 degree of freedom. And this has to be... this still could be the 8 dropping to a 7. But the 9 has to be one of these 2 digits. So this could be the 8 dropping to a 7. That's fine. If this was 6... so what does this... Okay, so that's a good question. What do these add up to then? We know this is 1, 2, 3, 4, 5, 6. That contributes to the 56. We know then... Okay, that's interesting. What does that mean? We also know this has to be an 8 then. This has to contain 8 because only the 7 can drop now because we have 1 degree of freedom going this way. Okay, so what are the possibilities? If this is 6 and... This has to be 6 and 9 if it goes this way. If it's 6 here, right? Because the 8 drops to a 6 because we have 2 degrees of freedom going this way. So that would be 6. This would be 7, 6. This would be 9. So that would be, what? 7 plus 6 plus 9 is 22. This would then be 7, 8, and 9. 24. 22 plus 24 is 46 plus 9, right? So then this would be 6, 9, 7, 8, 9, and this would be 9. So then this would require this to be, this would be 9, 7, 8, 9, and this would be 9. So that would be 18 plus 24, which is 42. So this would have to be 7. I think this is always 1 greater than this one, right? Right, because if this is 9, this then has to add up to... So this is, if this is 9, these two add up to 16. This would be 8. But yeah, it doesn't really matter too much. Basically, these are 16. These 5 would have to add up to 55 minus 16, which is 39. So this would be 7 plus 39, which is 46, and this digit would have to be 10, which is not allowed. So this can never be 9, which means in this box, where is the 9? It has to be here. So this is a 9, always, and this is always 2 greater than this digit here. Sorry, 1 greater than this digit here, right? Because this has to be the difference. These are the difference cells. All of these are shared. So, this is 7 or 9. So what happens if this is 8? If this is 8 and 9, this is 7, 8, and 9. First of all, this has to be a 9. This would be 24. So the remaining digits must add up to 31. This would be 8. This would be 9. So this could be 7 or 8, and this could be, yeah. So this is still pretty up in the air here. We don't know what it is. And this could be any of them. Right, because this could be 7 here, and this is 9. If that's the case, then this would be 7, 9, 7 plus 9. This would have to be 8. This would be 24 then. Plus 7 is 31, so this would be 7, 8, and 9. Okay. So we have that information. This cannot be 8 or 9. Huh. What happens if it's 6? If it's 6, this is at most 24. Actually, let's check 5 first. Can it be 5? This would be 8 and 9 at most. This cannot be 9. This could be an 8. So 8 and 9, it could be 9, 8 here specifically. That would be 17. This could be 8. 17 plus 8 is 25. And this would have to add up to 17, which is not allowed. Right? Because it requires an 8 and 9 here, and this one of these is 5. So this would be, again, 9, 8 at most, if this is 5. 9, if this is at least 5, at most 5. This becomes 8 and 9 at most. 17. This is 8 at most because one of these has to be 9. So 17 plus 8 is 25. 42 minus 25 is 17, and we can't have an 8, 9 here because one of these is 5. So that doesn't work. So this has to be at least 6 or 7. Aha. We now have a 6, 7 pair here. Which means the rest of the box cannot contain 6 or 7. It has to be 1 through 5. Interesting. Can this ever be 6 is the question, right? It probably can. Let's try. If this is 6, this could be 6, 8, and 9, which is 23. Plus 6. 23 plus 6 is 29. And this could be 8 and 4. Yeah, so it could be 6. Or it could be 7. We're not sure which. Similarly here, this can't be 5. Because if this is 5, well, again, you could have 9, 8, and 9. Plus 5 and 8. So 17 plus 9 is 26. But then this would also have to add up to 17, which is not allowed by 5 with anything. So this is 6 or 8 also, which means the rest of the box is also 1 through 5 here. Oh, this can't be 9 actually because of this 9, so that doesn't work that way either. It could be 6 or 8. Okay, so this is interesting. We can remove this diagonal. Well, actually, let's just keep it, I guess. There's no reason not to. So it can go up to 8. So it could go up to here. That's interesting. This can go up to 7. So it goes up to here. Huh. Interesting. Okay. This is also 42 going this way. So, say this was 8 or 9. Well, okay, so we've proven, I think, that it can never be 5 going this way, right? If it's 5 or less, you have 5, 8 and 9, 8 and 9. Or 9, let's just say. That would be 8 and 9, which is 17, plus 9, which is 26. This would have to add up to 16 with a 5, which means this would be 11, which is not allowed. So this has to be 6 or 7. But if we try to make it 8, how does that work? That means all of these cells would have to add up to 42. But even if this is 7, say this was 7, these would have to add up to 42, and then you subtract out 7, you know then that this would have to be 35 for just these 6 cells. And 35 plus 8 already is 43, which is greater than the sum here. So this can never be 8 or 9. It can't be 5 or less. It has to be a 6 or a 7 here, too. This can't be 6 or 7 because of the 6-7 pair now in the row. So interesting. If one is 6, the other one has to be 7. If this is 6, that means it would just be those 6 cells adding up to 42, right? The problem is these 7 cells then so these are essentially always going to be okay. So then we have another set. I don't know, let's make it pink. That has to always be up to here, right? If this is 6, that means these cells, so this could be at most 5 and 6 here, right? I guess it could still be 6 then, right? If this is 5 and 6, that's 11. This is at most 6, 8, and 9. 23 plus 11 is 34, so this could be 8. So that's possible. So 6, 8, and 9, then this would be 6, 8, and 9. This would be 8. If this is 6, this becomes 7, 8, 9, and this is 7, 9, which is fine. If this is 7, so if this is 6, this has to be a 5, and this is 8. This is 6, 8, and 9, so that's 23 plus 8, which is 30. 23 plus 8 is 31, plus 11 is 42, so that works. And this would be fine. We have a 6, 8, 6, 8 pair here, interestingly enough. So this could not be 6 or 8. So the rest of the column cannot be 6 or 8. So we have 1, 2, 3, 4, 5, 7, 9. Obviously, 7 cannot be here. That's interesting. This can't be 7 either, so one of these two is a 7 here. What does that mean? I'm not sure. What are the digits that can be here? Obviously, it can't be 1, because that doesn't add up to 10. It could be 2, could be 3, could be 4, because you could have all, this could be, can it be 5? Then it would be 5, 1, 2, 1, and 1. Yes, it could be 5. That's possible too. What else do we have? 43. Oh, it's interesting. The same this way as the same is the same. So whatever digit this is has to add up to 36 for these and then 42 for these, right? So we'll mark these as possible. Hmm. So if this is 6, this has to be 5, this has to be 8, this has to be 9 with 6 and 8 here. So this is 23, this is 8, so that's 31. So these must be add up to 11. This could be 7 with 1 and 3, or 7 with 2 and 2, and those both work. What would be the maximum then here? If this is 11, 7, 2, 2, that's 11. This would have to be at most 8. So 7, 2, and 2, 11 plus 8 is 19. Therefore, these 4, so assuming 8, these 4 would have to add up to 43 minus 19, which is 24. Which is possible. Yeah, 8. This could be 8. And this could be many digits. What happens if this is 7 and this is 6? That's interesting. Can this ever be 6 is the question, right? Maybe. If this is 6, can this ever be 8? Or sorry, can this ever be 7? Oh, interesting. If this is 8, that forces this to be 6. But then that forces these sets to be 7, 8, and 9. This would be 7. Okay, so the only time this is 7, 8, and 9 is if this. So if we have 7, 8, and 9 here. I guess this could be 7, 9, 7, 9. That's possible. Okay, but if this is 8, this has to be 6, which means this is 22 here. Therefore, the rest have to add up to 33, which means this is 24 and this has to be 9. So this is 7, this is 9. This must be 7, 8, 9, which makes this a 6 and this a 7. I guess that's possible. I was thinking that it would cause a problem, but it doesn't. Hmm. Okay, huh. Um, this cannot be 9. Can't be 1. Can't be 2 or 3. Because, yeah, that doesn't add up to 40, 22. It could potentially be 4. 4 plus 4 plus 5 is 13. Oh, plus 9. No, it can't be 4. So this has to be at least 5 here. So it's 5, 6, 7, or 8, potentially. Can't be 9 because of that 9. Um, hmm. Okay, so if this is 6, that's interesting. If this is 6, oh no, other way around. If this is 8, this is 6, which means this is 22. This has to add up to 33. So this is 9, this is 7. This has to be 7, 8, 9. This has to be 8. This is 7, and this would be 9, which would force this to be a 6. Therefore, this is 5, this is 8, this is 6, 8, and 9. So this is 9, this is 6 and 8, this is 6 and 8. That's actually very interesting. This is a 7. So these, with a 7, this is 23, plus 8 is 31. These must add up to 11. This is... interesting. That means this is 15 already. This is, okay, so this is 11. So this is 11. This is 8, so that's 19 here already. So these 3 plus this digit must be 43 minus 19, which is 24. Right? What does that make this is the question. So this is 8, and this is 8. So this is 8, 8 here, 8 here. This would then be 7? No, 2, 4 here. So 8 here, 8 here, and then 7. Okay, so that would mean, and this is 4. So it's 16 plus 4 is 20 plus 7, 27. So this is 16 here. Right? This would be 16 plus 7 and 8. And these two, which could add up to 5. That works. Okay. Hmm. What about this? Oh, that's interesting. These are sort of competing with each other here. Um, they could be the same amount. Technically, 20 could be bigger. Maybe? Hmm. It always we can know it always can be smaller, but can it ever be bigger is the question, right? If it's bigger, it would have to be this is 6 and this is 5. Because if it's 7 and this is 6, then all 7 would add up to 20, but then this would say 6 add up to 22, which is not allowed. If all 7 add up to 20, right? Because you can't have a negative value in normal Sudoku. Hmm. So it would have to be this is 6 and this is 5. But if this is 6, then this would add up to 14. And 14 plus 5 is 19, and that doesn't work. So this cannot be smaller. Sorry, this one cannot be bigger than this cell. It could potentially be the same if they're both 5s. If they're both 6s, obviously it can't be the same. But if they're both 5s, this could be 5 and this would be 5. And this could be something like 5 here and 3 here. So these two would be bigger, right? Um, can it be 8? Maybe? It can't be, it could be 4 here. If this is 4, it could be a 9 here technically. And something else. Yeah, so this could be 4. It could even be 3. So this could be 3, 4, 5, 6, or 8. Okay. What else? We tried this being 8. That seemed to work fine. 6 doesn't seem like it limits much either. Maybe it limits a decent amount. Actually, what is this if this is 6? If this is 6 and 8, this is 5 and 6 at most. This is 8 at most. Oh, maybe that's an interesting aspect. Okay, so if this is 8, this has to be 6, which forces this to be 7, 8, and 9, which forces this to be 6, which makes that a 7. So if that's the case, what happens if this is a 6? If this is 6, this is at most 11, this is at most 8, so that's at most 19. The rest would have to be 7, 8, 9. So therefore, this is a 7 either way. Interesting. Okay. So if this is 6, sorry, if this is 8, this becomes a 6, which forces this to be 7, 8, and 9, because we've lost all our degrees of freedom here from the 8 going to a 6, because we lost 2 degrees of freedom. We only had 2 degrees of freedom. Therefore, this is 7, 8, 9, which forces this to be 6, which forces that to be 7. If this is a 6, though, this is at most 5, 6. This is at most an 8. So therefore, these 3 digits are at most 19. And these 3 digits are the rest, which must be 43, must be at least 43 minus 19, which is 24. And 24 at maximum requires a 7, 8, and 9 pair. Therefore, this is 7. So either way, whether this is 6 or this is 8, this is always 7. So this is 7, this is 6. This cannot be 6. So therefore, we know this, along this x sum, you have 1 degree of freedom. We haven't used it here. We haven't used it here. We haven't used it. Well, that was already set. Aside from that, we have 1 degree of freedom. Therefore, this must be a 7, 9 pair here, specifically. Because that's the only degree of freedom we have left. This is 6, which requires then this to be 6, 8, 9, 6, 8. So therefore, this has to be, we know this is 5. This is 6 and 5. This has to be 8. This has to be a 6, 8 pair here. And this has to be a 9. Which means 9 cannot be any of these. Because this is the minimum. The maximum here is 23. The maximum here is 8. The maximum here is 11. And that adds up to what it actually is, which is 42. So this can't be orange. This is 7. It adds up with all these. So this has to be either 1, 3, or it's 2. Actually, this could be, yeah, because this is 23, this is 8, that's 31. Therefore, this adds up to 42 minus 31, which is 11. So this is either 1, 3, or it's a 2 pair here. We're not sure which. Okay, so this can never be 6 anymore then. If this is 6, that forces all of these to add up to 43, but we have a 1, 2, 3 here at minimum. So that's 3, 7, 9 at maximum. That's 20, or 19. 19 plus 8 is 25, plus 5 and 6 is 36, which is not anywhere close to the 43 we need. So this has to be 8. This is 6. So the yellow is all the way here. The pink has to include here. So we can remove all the pinks. The yellow has to be including here. The red is all of these. And this is 1, 2, or 3. Can this ever be 6 is the question. Well, okay, so here, this can't be 3 anymore because it can't add up to 20 with just 3. This can't be 5. None of these can be 5. Oh, that's interesting. So can this ever be 8 is kind of the question. Because this is at least a 6. I guess you could have 1, 2 here, 1. So we know this is 11. This is 8 at most. This is specifically 11. This is 8. So that's 19. So these three, and that has to be 24. What's the most this can be is the question, right? This could be 1 and 1 here. Which would be, so that's 15 plus 2 is, what's the minimum here? I guess maybe that's a better question. This can't be 8. We have a 7, 9, 7, 9 pair here in column 7, which eliminates 7 and 9 from the rest of the column. Therefore, this is 1 through 6. So this is at most 5 and 6. Okay, what's the most here is really the question, right? So the most here is, this is definitely 4. The most here is 12. So it's either 10 or 12 here. So this is 10 or 12. If this was, say, 10, that means the rest of this would be 33. Yes, because this is 10, subtract 10 from 43, it's 33. So this is 33, which would require this to be 3. So this would be 1 and 2 specifically. If this is 12, that means this is 31. So this adds up to 5 at most. So this cannot be 5 or 6 here. So this is specifically 31 or 33. So this is either 16 or 18 for these 3 cells. Okay, so that doesn't limit things very much there. We have a 6-8, 6-8 pair here, so 8 must be one of these three. Okay. This is at, okay, cannot be 3, because the most then would be 3, 5, and 6 in this box. So it has to be at least 4 to add up to 18. And that would include a 5. Can it be 5 here? I think it could be 5 here. Can it be 6 here? Maybe. This is 4, 5, or 6. Can this be 5? 3, 4 plus 5 is 12. Plus 8 and 2. Yeah, it could be 5. Can it ever be 8? I don't even think it could be 7 even. Can it be 7? If it's 7, this is at least a 4, right? Okay. If this is, how many does this actually, can this actually be less than? I don't think it could be less than 3, right? If this is 4 and this is like, say, 7. Actually, even 4 and 6 doesn't really work, right? If you have 4 and 6, yeah, so if this is 4, this has to be 5, if that's the case. If this is 7, this has to be 5 at least? No, because, again, 5 would be, that wouldn't work even. So this can't be, if this is 7, even if this is 6, that's 22 minus 7, right? And if we tried 5, that's even worse, right? So 22 minus 7 is 15, and therefore 6 wouldn't add up to 15. So this can never be 7 or 8. This is 5 or 6. It can't be 6. Oh, we know it's 5 then. Okay. Well, there you go. So these 5 add up to, this is not blue. This could be 5. It's 4 or 5. It cannot be 6 or 8 here. This is 5. So it could be like 1, 4. And then this adds up to, so this has to be, this is at most 3 and 4. So that's 12, which means these are 10 at most. Right? Or 10 at least. Yeah, 10 at least, which means this has to be at least 6. So this is 6 or 8. This is at most 12. Again, you can't have 4 because 4 plus 3 plus 4 plus 8 is 19 at most, and you can't get to 22. And it can't be 7, again, because we tried 7, and then the problem is, what if this can't be 7 either, because that would have to add up to 22, and if it's 6, these would be 22 minus 7, which is 15, and that's not allowed. That doesn't add up to 20. So therefore, this must be, it can't be 6 because this has to be a 6, so it must be 5 then. It could be something like 1, 4, and this is 4, 8. We have a 6, 8, 6, 8 pair now, though, in... Oh, that's interesting. This must include both. So this is double what this is. So if this is... Because this can't be 3, because 3 plus 8 and 9 adds up to 20, but 3 plus 8 and less than 9 does not. So it has to be 4 or 5. Already, if this was 8 and 8, which would have to be the same, these have to be the same digit, because they both see that digit, and this digit is the other 6 or 8. So, if this is 8 and 8, this is already double that. So it's 4, 8, and 8, so that's 20. And then this would have to add 21. So this cannot be 8 and 8. This has to be a 6, which makes this an 8, which makes this a 6. Oh, that's interesting. So this is 6 and 6. That's 12. This still could be 5. This then is already changed. So this is now 6, 7, and 8, which is 21, plus 4, which is 25. So this is 18 here. So we have 18 here plus 15. This is must add up to 3. So this adds up to 3. This adds up to 18. This is 6 and 8. This could be 4, or it could be 5. This is... Oh, what's the maximum now here? 3, 4, 5, and 4. So this can never be 5 here. Right? If this is 5 and 6, I guess it could be 2, 4. Yeah. Sorry, this has to be at least 4. This is at most 3 and 4. This has to be at least 4. Well, at minimum, this is 4 and 4. 4 and 4 plus 6 and 6 adds up to 20. So at minimum, this is 4 and 4. So this has to be specifically then 4 and 4 because that matches the amount we have. If we tried 5, obviously it's greater than 21 or 20, so therefore that doesn't work. Therefore, this is 4 and 6. This must be then specifically 3 and 4 to add up to 22 for these 5. So this is set. This is set. We have a 1, 2, 1, 2 pair now in column 8, which eliminates 1 and 2 from the rest of the column. These can't be 5. Where is the 5 in column 7? It has to be here. So this is a 5. Okay, so then these 5 add up to 18. 6 can't be here, 6 can't be here. Where is the 6 in box 3? It has to be here. The remaining cells has to be 1, 2, 3, and 4. And we have a 1, 2, 3, 4 quadruplet in column 9, which eliminates 1, 2, 3, 4 in the rest of the column. Therefore, these have to be 7, 8, 9. This can't be 7 or 8 because of this 7 or 8, so this must be a 9, which means this can't be 9. This is 7 or 8. Well, 3 and 4, where are the 3 and 4 in column 9? It has to be these 3 cells. So this cannot be a 3 or 4. It's 1 or 2 here. So at maximum, what can this be? 5, 2... Okay, so this is at least 8, which means this is at most 10. It could be 1, 2 with 3 or 4. That's possible. What it cannot be is 1, 2 plus 1, 2. Right? Because then this would be 8, and this would have to be 10. But this can't be 10. This is 9. So this can't be 1 or 2. It's 3 or 4 here. This can't be 4, so this must be a 3. That's interesting. So this can't be 3 here. This can't be 4, whereas the 4 in box 3, it has to be here. So this is 4. This can't be 4, obviously. These can't be 4. We have 1, 2, 1, 2. 5 cannot be here. This is, it could be 10. Okay, so it could be 10 or 9. That's fine either way. This is 4. This can't be 4 then. Okay, so this is set. Kind of. This is set. This has to be 7, 6, 9, which means this is essentially 24 plus 22. Therefore, this is a 9. So this is 9, this is 7, which makes this a 9, which makes that 8, which makes that 7, which makes that an 8. Okay. So 9 cannot be here. Again, this adds up to... this is 11. This is 6. So this is, okay, 25 here, which makes this 18. So this is at most 8. This is at most 8. This is at most 8. We know 8 plus 8 is 16. This has to be at least 18. So this has, or specifically 18. So this cannot be a 1 here because 1 plus 8 doesn't add up to 18. What's the minimum either of these could be? Well, the maximum here is 8 and 5. So the minimum would be 5 because it has to add up to 18 exactly. So this is at least 5. So, but it can't be 5 here. So this is 6 or 7. This could be 5, 6, or 8. And this is 2, 3, 4, 5. Okay. What else do we have here? The remaining digits in box 2 are 1, 2, 3, and 5. But, okay, so this can't be 3 here. This can't be 3. We now have a 1, 2, 5 triplet in row 3, which eliminates 1, 2, and 5 in the rest of the row, leaving a 6 and a 7, but this can't be 7, so this must be 6, which makes this a 7. If this is 2, this is 2. If this is 1, this has to be 3. So this can never be 1 here. This is 1 or 2. This makes that 2 or 3 to add up to 11. Or sorry, 4. But 11 with this, essentially. Because this already adds up to 31. Therefore, this must add up to 11. This is a 7, so this must be add up to 4. Okay. This can no longer be 5, because if it's 5, it would require 1, 2, 1, 2, 1, and 1 required. So this cannot be 5. Either this is 2 and 8, or this is 3. If it's 3, it cannot be 1 and 6, because 6 is already in the box. And it can't be, yeah, it has to be 3. If it's 3, it's 2 and 5. So if this is either 2 and 8, or this is 3, this can't be 5, so this would be 2 and 5. Either way, the 2 has to be one of these two cells, which means this can't be a 2. This must be a 1, which makes this a 3. Okay, that's interesting. I don't know if that tells us anything. This can't be 3 then. This can't be 1. So now we have a 2, 5, 2, 5 pair in box 2, which eliminates 2 and 5 in the rest of the box. 5 has to be one of these two cells. And we also have a 9 in one of those two cells. And it's specifically then a 5, 9 pair here. This is a 5, 9 pair because we have a 1, 2, 3 triplet here. This cannot be 1, cannot be 2 because one of these is 2. It could be 3 or 8. Okay. This can't be 7. One of these 2 is 7. Okay, so these have to be 3, 4, or 6. Well, this can't be 6, so this has to be 3 or 4, which makes this a 6. Okay. One of these is a 6, and one of these is a 6. So okay, so can this ever be 6, 6? No. Right? If this is 6, this has to be a 6, which means this is double. But if this is 6 and 6, that adds up to 12, and this adds up to at most 5. So that would be 17, which is one shy of the 18 we need for this X sum. Right? Because this is 11, 17, 25. 43 minus 25 is 18. And if this is 6, 6, that doesn't work. So this cannot be 6, 6. Therefore, this is 6 and 6. 7 is one of these two cells, and 7 is one of these two cells. We're not sure which. This is 3 or 4. Okay, so let's stop coloring the diagonals because we have all those set now. And let's start coloring what these can be, right? So this has to add up to 3. So this is specifically different from this. Oh, that's interesting. Okay, well, that makes a big difference. We know these have to be 1 and 2, and they have to add up to 3. And they have to be different. So this is 1, and this is another one. Well, they both see here. This can't be 1 or 2 then, which makes this a 3. This can't be 1 or 2, and can't be 3, so this must be 4. So this can't be 3 or 4 here. This can't be 3 or 4 here. One of these is 1. We have a 1, 2, 5 triplet here in column 6, which eliminates 1, 2, and 5 in the rest of the column. Therefore, this must be 3 or 4. We now have a 3, 4, 3, 4 pair in both row 5 and row 6, which eliminates 3 and 4 in the rest of the row. This can't be 7. So this has to be a 7 here. We have a 1, 2, 1, 2 pair in row 4, which eliminates 1 and 2 in the rest of the row. Therefore, this has to be 4, 8, and 9. But neither of these can be 4. So this is 8 or 9. This is 8 or 9, which makes this a 4. Okay. We have a 2, 5, 2, 5 pair in column 4, which eliminates 2 and 5 in the rest of the column. That leaves 1, 3, 8, and 9 as possibilities, but these cannot be 3. Therefore, we have a 1, 8, 9, right? Because it can't be 2, 4, 5, 6, 7. It has to be 1, 3, 8, 9. We have a 1, 8, 9 triplet now in column 4, which eliminates 1, 8, and 9 the rest of the column, and in the same box. So this can't be 1. This is a 2. This can't be 2 or 1, so this is a 5. This 2 means this can't be 2, so this is 1, which makes this a 2. This 1 means this can't be a 1, so this is a 2, which makes that a 1. So this can't be 1. This cannot be 3. This has to be 1, which makes this a 3. This 1 means this can't be 1, so this is 2, which makes that a 1. This 2 means this can't be 2, so this is 3, which makes this 8, which makes that 2, and this is 5 to add up to 10. This has to be 9. Okay. This is 1. This is 2. This is specifically 7 with 1, 1, 3, 4, 7, right? But this can't be 7. This can't be 1. Okay, so we have those. This can't be 3 or 4. So this is 1 or 7 here. This is 1, 7, or 8 as the rest of the row, but it can't be 7 or 8. So that forces this to be 1, which makes this 7, which makes that an 8. This has to be a 7. This can't be a 7. This is the 3, 4, 3, 4 pair now, which forces this to be a 1. This has to be 2, 5, or 9. It cannot be 9, 2 or 9 here, so this has to be a 5, which makes this a 2. And this has to be a 9. This can't be 2 anymore, so this is 5, which makes that a 2, which makes that a 5. This can't be 8, so this is 9, which makes that an 8. This can't be 5 here, so this must be an 8. That does add up to 18, which is great. So therefore, this can't be 8. This can't be 8. The remaining digits here, this can't be 9, so this has to be 1. Or actually, it doesn't work. This can't be 9, so this is a 1, which makes this a 9. And the remaining digit here is a 5. Which leaves this as a 2, whereas the 2 in row 5, it has to be here. This then cannot be, it has to be a 1. Therefore, this is a 4. Let's see. This has to be a 3. And now, let's see. This adds up to 18 here. So this must be, this is 10. So this must be 3, which makes that 4, which makes that 3, which makes that 4. That's a 3, and this is a 4 then. And that's how you solve it. Very cool, actually. I always like new rule sets that make sense, and this definitely makes a lot of sense for this rule set. And, you know, I would put this probably in between challenging and hard, but, you know, hard, you could fit, you know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.